Okay. Good afternoon and welcome back to the post-lunch session. We have come to the last session of this workshop on AI and digital content creation. And the last speaker of this workshop is Dr. Anul Acharya, who will be speaking on generation of concept maps using AI techniques. Dr. Anul Acharya is the Assistant Professor, Department of Computer Science and Xavier College, Kolkata, Autonomous. Dr. Acharya is an accomplished academician with over 27 years of teaching experience at the undergraduate and postgraduate levels. Dr. Acharya completed his MCA from Jadavpur University in 1997 and later earned an ME in Information Technology from West Bengal University of Technology in 2006. He was awarded a PhD in Computer Science and Engineering from the University of Calcutta in 2017 for his research on data mining techniques in web-based learning. Dr. Acharya has held key administrative roles, including head of the Department of Computer Science and chairman of the Board of Studies during the period when St. Xavier's College gained autonomous status. His research interest focuses on educational and social data mining. As a principal supervisor in the PhD program at St. Xavier's College, he has guided numerous postgraduate dissertations. Dr. Acharya is known for his expertise in design and analysis of algorithms, artificial intelligence, and machine learning. He has an extensive publication record with over 50 papers in international journals, conferences, and book chapters. Dr. Anul Acharya, I would please request Father Julian Das to come and felicitate Dr. Acharya. We will now go for the presentation on generation of concept maps using AI techniques by Dr. Anul Acharya. May we please have the lights of the dais off for the presentation to begin?
ঠিকই ছিল এটা কি ক্যামেরা নাকি আচ্ছা কথাবার্তা এখান থেকে রেকর্ড হবে ঠিক আছে কিছুটা তো ঘুরতে পারি এদিক ওদিক ঠিক আছে ঠিক আছে Thank you ma'am for your generous introduction. So it's indeed a pleasure to come to EMRC and discuss a new topic related to artificial intelligence. So I have been working in this field for quite a few years, and as ma'am has already said that my PhD topic was basically on this topic actually, that was generation of concept map using AI techniques actually. So we had used the concept of, we had used a tool called concept maps, which I am going to discuss, and then we are going to proceed after that. So I would like to first start by acknowledging our Father Principal, Reverend Father Dr. Dominic Xavier. So Father has always been our inspiration, and he has always encouraged us to go for research and higher studies. I would also like to acknowledge Professor Devadatta Sinha. So he was my supervisor, and he was also an advisor to me when I was doing my PhD. So he was the professor and the head of the Department of Computer Science and Engineering in University of Calcutta. So first, the agenda. So what we are going to discuss. So first we are going to basically study three techniques, three things actually. What are they? So first we are going to generate concept map using data mining heuristic. So I'm going to introduce the term heuristic. What is a heuristic? Heuristic is basically a rule in AI. Sometimes what happens that whenever we want to perform certain computation, so what happens is that the computation becomes quite large and expensive. So heuristics are used in such circumstance so as to reduce the computation. Sometimes what happens is that maybe in certain computations we don't need that much of an accuracy, but we need faster results. So wherever we need faster results, we depend on heuristics. So heuristics are basically the backbone of AI. Next, so over here what we are going to do, we are going to generate a learning path actually. We'll come to this actually. Then in the second section we are going to optimize that path. We are going to optimize that path using concept map. So that will give us something called remedial learning path. And third is that this is totally our new concept, that we had developed a concept map which is an extension. We had developed a weighted concept map which is actually an extension of concept map. Okay, so what is our starting point? So we are starting with something called initial intelligent tutoring systems. So initially the learning maps that are there, so all of them were intelligent tutoring systems. Intelligent tutoring system means there were certain materials which the students used to learn, and after that they gave the exams, and the system provided the results actually. Okay, so that was what is, in summary, what is intelligent tutoring systems. So these had been developed basically for e-learning and m-learning environments. So when we did this research, so e-learning and m-learning, they were very much a little bit of different actually. E-learning means we had used computers for e-learning, and m-learning means basically mobile learning. So nowadays we generally refer to them as ubiquitous learning. Both of them are together. Mobile and computer is used together analogously. So over here, this intelligent tutoring systems that are developed, so these had two disadvantages. What are the two disadvantages? First is that it does not provide a specific feedback about learner problems. A person is giving an exam or a person is studying something. So when a person studies a concept, obviously he may have some difficulty where exactly the problem is. So we would like the system to give some sort of a feedback where exactly the problem is. And second thing is obviously the lack of mind tools to organize knowledge. What is mind tool? Mind tool is actually some sort of a pictorial representation. So we want to represent something in a pictorial fashion. As an example, let us suppose we have a certain subject which is being taught to a set of students. Now the subject may be divided into a set of concepts actually. Okay, let us say there are 5 concepts. So the concepts are being named as C1, C2, C3, C4, C5. I can give an example actually. For example, over here. So we have a certain subject. So corresponding to this subject, there are 5 concepts. So the concepts are being named as C1, C2, C3, C4, C5. Now here we find that there is an arrow over here. So this arrow means first the concept C1 is to be learnt. Once the concept C1 is to be learnt, then the concept C3 will be learnt. Okay. So if a person has, let us suppose a student appears in a test on the concept C3, and let us say he fails in that test. So if he fails in that test, in that case what happens? In that case it can be assumed that he has not learned the concept C1 properly. So he is asked to revise the concept C1 in that case. Okay, this is the idea. So this is what is a concept map, and this is an example of what we say as the mind tool. Okay, so mind tool means this is a tool basically to organize the knowledge. So these are the two problems that are faced in intelligent tutoring systems, and this is what we intend to overcome. So as I said, the learning systems that are there, so they should be able to generate some form of learning aid for the learners in a timely fashion. Okay, so learning aid means what? Learning aid means, let us suppose I have not been able to assimilate a concept. So if I have not been able to assimilate a concept, then where exactly the problem is? Why am I not able to assimilate the concept? So that is what our target is to find. So these concept maps, they may be used in organizing knowledge. Okay, knowledge means basically the set of concepts that are shown one after another. So that constitutes the knowledge. Achha. So this thing I have already said. So concept map, what is a concept map? So concept map is basically a graph. Graph theory is something that we associate a lot in computer science. So this is a graph basically. So it contains a collection of association rules and correlation coefficient. What is this association rule? For example, over here we have C1, C3. What does it mean? That means a student will first learn C1. After learning C1, the student will learn C3. So the rule is that C1 implies C3. That is how we write the rule. Similarly, we have C3 arrow C2. So what does it mean? How is it written? It is written in this form. The C3 implies C2, right? So associated with each of these rules that are there, there is a coefficient. This is called the correlation coefficient. What is the meaning of correlation coefficient? Correlation coefficient means to say that if a student is not able to understand C3, okay, right? So it means that there is a probability of 0.45 that the student has not been able to learn C1. Okay, this is the idea. I'll repeat this once more. So over here, this coefficient means that if a student has not been able to understand or learn C3, that means that 0.45 is the probability that he has not been able to learn C1. Okay, so a high probability in this case. Similarly, over here we have C3 arrow C4. That means to say that if a student has not been able to learn C3, there is a probability of 0.14 that the student has not been able to assimilate C4. Okay, this is the meaning. So these things are written. So concepts, these are called vertices. These circular things that we have, these are called vertices or nodes, what we may call. Okay, right? So these are the sequences. Okay, for example, here we have a sequence like this. If we start from C1, what is the sequence we have? We have C1 arrow C3, C3 arrow C2, C2 arrow C5. Okay, and you will find out that from C5 again we have again C3. So this is what in terms of graph theory we call a concept. We call a cycle actually. So obviously a cycle is something that is not desirable, isn't it? If we have a cycle, what does it mean? That means which concept should we learn? Should we learn first C2, C5, C3, or should we learn C3, C2, C5, or should we learn C5, C3, C2? What is the actual cycle, that actual path that we will use? Okay, so that is what we are going to check also. So over here we have constructed a framework. So framework means there are, as we know already, that there are two types of applications in terms of learning. One is personalized application and another is collaborative application. What is personalized application? Personalized application means, let us say a system is being created. So system is basically created for a single student only. Let us suppose I have appeared in an exam and then I have done poorly in that exam. So for me, if a system is constructed, that is called the personalized. Okay, that is actually, this is called personalized learning actually. Then there is something called collaborative learning. So collaborative learning means, as the name suggests, a group of learners are there, 5 or 6 persons, they can collaborate among themselves and they can learn a subject. Okay, so that is called collaborative learning. So personalized and collaborative learning, they can be used in both types of environment. They can be used for e-learning environment, they can be used for m-learning environment also. So in case of personalized application, what is our target? So provide individualistic message for remedial learning. See, we are focusing on this word individualistic. Okay, so because it is personalized, that is why it is individualistic. That means it is for one single individual. Collaborative application means promote learner discussion. Whenever we say collaborative, okay, let us say we often give projects to our students. So whenever we give projects to our students, so we often tell them to collaborate among themselves, isn't it? And sometimes we often observe that if there is a group of 5 people, there is often a fight between themselves and so on. This is what we find as teachers. That means they are not able to collaborate. Okay, so the purpose of giving projects to students is basically for having learner discussion. Okay, so these are the learner objectives that we have. Similarly, corresponding to e-learning and m-learning environment, right? So there are again certain objectives. So in case of e-learning environment, a computer, it is assumed, has a high amount of power, computing power, so it can provide testing and diagnostic mechanisms, and over here it is providing immediate guidance. Next, what is our objective? So here we are coming to the subject actually. So our task will be basically to generate a concept map of learning in personalized environment. So in this discussion we are talking of personalized environment. So what is the algorithm that we are using? So we are using an algorithm that is called the direct hashing and pruning algorithm. So this is the algorithm that we are going to use. Okay, so we are going to implement this using a suitable learning theory we are going to use here. Okay, we are going to use a suitable learning theory in m-learning. That means this algorithm we have developed, so this was in a computerized fashion. This we had developed in a m-learning environment, and obviously due to the lack of time we could not implement it actually. So what we had done, we had developed a prototype of this using an Android emulator. And any study that we perform, so to understand how good the study is, we have to use some form of statistics. So we had used multivariate regression analysis to determine the effectiveness of learning. So nowadays whenever students are given to use multivariate regression analysis, they often use the Python language. So over here we had used the SPSS software, statistical package for social sciences, we had used over there. Achha. Now concept map generation. So we are coming to the concept map generation. So several researchers, they have used several techniques for concept map generation. For example, there was a test called SPRT, sequential probability ratio test. This has been used by one researcher. Then there is something called fuzzy set theory. Then we have a priori, right? Fuzzy set theory, a priori. So all these things has already been used by various researchers at various point of time. Okay, right? So all of them work by constructing a candidate set of large item sets. Item set means, what are these item sets actually? So we are going to give the students certain questions. So those questions are going to be called as item sets. So here after this we had used hash based technique in this study. So the purpose of hash based technique was basically to reduce the number of candidate item sets. Okay, so basically this entire thing, concept map generation, there are 2 phases to this. What are the 2 phases? One is that we have a preliminary concept map which we are constructing first, and then the preliminary concept map that is there, we shall see that there are various problems associated with that. For example, one example already we have seen that it contains cycles. So what will be our aim? Our aim will be to remove the cycles. So that is called as the learning sequence. Okay, whenever we have a sequence, so if it contains a cycle, let us suppose there are 5 nodes, C1, C2, C3, C4, C5. From C5, if we are given to come back to C1 again, okay, so obviously it does not form a sequence, isn't it? We don't know where to start from. So basically we should identify where to start from and where to end. So that is one of our targets. So these are the algorithms. So we won't look much into these algorithms actually. So basically I have taken an example. So I will run through this example how it works. So let us say there are 4 students, they are identifying as S1, S2, S3 and S4. So they appear in a test containing 5 items. Items means, let us say, a set of questions. So these questions has been written in this format: Q1, Q2, Q3, Q4 and Q5. So there are 5 questions, right? So over here these are the students and these are the questions, and we have marked as 1 and 0. So please note that we have taken student wise wrong answer. Why have we taken as wrong answer? It is wrong answer. That is because we want to identify the concepts they are weak in, not the concepts they are strong in. Okay, so that is why we are trying to identify the wrong answers. So we have here Q1, Q2, Q3, Q4, Q5, and we have these students S1, S2, S3 and S4. So corresponding to the student S1, there are 3 ones which we are taking. So he has answered wrongly the question Q1, Q2, Q4. Student S2 has wrongly answered Q2, Q3 and Q5. So corresponding to this, what is being done? The 2 item sets are developed. So here this table 3.1, it contains 1 item set. That means there is 1 item only. Okay, right? So we are going to identify 2 item sets. Okay, so we are taking, for example, we are combining Q1, Q3, Q3, Q4 and Q1, Q4. In this way we are identifying. Alright, so over here we have used a hash function, right? So we have taken the hash function as order of x into 10 plus order of y mod 7. The whole thing we have taken mod 7. We have divided the mod of this and we have generated a location. So using that, what we are doing, we have generated a set of buckets. For example, over here we have taken 7 buckets. Why 7 buckets? Because you will find out that it is mod 7. So since it is mod 7, we are starting from 0, and where we will end up? We will end up at 6. That is why mod 7. Okay. So bucket number 0, there are 3 items, that is Q1, Q4, Q3, Q5. Okay, and also Q3, Q5 occurs twice, so it is being shown here, right? So bucket count is 3, right? Corresponding to bucket number 1, we have this Q1, Q3. Corresponding to bucket number 2, we have 2 items. We find that there are no elements in bucket number 1 and so on. Okay, so from this we are choosing the item sets. Which one shall we choose? So we are choosing this Q1, Q3, Q2, Q3, Q3, Q5, again Q3, Q5. Okay, next we are defining a table. What is the table we are defining? We are defining something called TIRT. TIRT means test information relationship table. Okay, so what is this test information relationship table? As an example, let us say this is question number 1. So question number 1 contains C1 0.75 and C5 as 0.25. So what does it mean? That means for answering question 1, we need to, the question, answering question 1, right, 75% of it is the concept C1, okay, and 25% of this is the concept C5. Similarly, let us say for answering Q2. So for answering Q2, 45% is required from concept C2, 55% is required from concept C5. Okay, so this is called TIRT. That means the relationship between the questions and the concepts. So corresponding to each of the 2 item sets, the association rule deduced as follows. So this is the standard formula that is used in some books of data mining and data analysis. So this is used for generating the amount of support. For example, Q1 comma Q3. So for Q1 comma Q3, we see that the association rule is 100%. Between Q3 and Q1, it is 66%. Between Q2 and Q3 again it is 66%, and so on. So over here we have said that the threshold is 60%. So why is the threshold 60%? That is because the pass marks are 50%, so we have just kept it a little above that. So each of the rules we find have a value greater than 60%. So what is being done? All these rules are being chosen. Okay, so based upon this, what we have done? So we have developed associations between the concepts. So we are computing the association between the concepts in this manner. Okay, right? Q1 arrow Q2. From this we have said we have used C1 arrow C2. So it is giving us 0.30. Similarly, between Q3 and Q5 it is 0.19. Between Q3 and Q5 again it is 0.16, and so on. Okay, so using these are what we called as correlation earlier. We had called these concepts correlation. So we have got two things. One is we have got these rules which are the association rules, and from these rules we have got the correlations. So using this actually we have generated this concept map, okay, which I had shown at the start of our discussion. So this is the concept map that has been generated from there. Okay, Achha. So that is the concept map we have derived. Now over here, as I said, what was the problem we had? What was the problem over there? So problem over there is that concept map, it contains a lot of cycles. Okay, right? So cycle means we do not know which concept to start from, isn't it? For example, again if I go back to that slide, over here we will see that we have a cycle here, C3, C2, C5, C3. Now if I just think of this as a subgraph, having three concepts, C3, C2 and C5. Now question is, which concept should I learn first? Should I learn the concept C3 first, then C2 or C5, or should I start with C5, then C3, then C2, and so on? So that is a major problem. So for that we have to simplify this graph and create a pattern that is called the remedial learning path. So remedial learning path means what path will a student choose for learning. So that is, this is the algorithm. Again I won't go to this algorithm. So we had used over here a concept of graph search. So there are two types of graph searches. One is depth first search, another is breadth first search. So we had made a modification of breadth first search, and using that we had developed this learning sequence. So what is the learning sequence that we have over here? What is the learning sequence that we have over here? Okay, so learning sequence is basically like this. We can start from C1. So from C1 we find that there are two paths, C3 and C4. What does it mean? That means once a student has learnt C1, he can learn C3 and C4 simultaneously. Then from C3 and C4 there are two arcs which are coming to C2. So that means once the student has learnt C3 and C4, he can then learn C2. From C2 he is coming to C5. So this is the path that we have developed. So we had a concept map. From the concept map we had developed this learning sequence, right? So this is one of the algorithms we had developed. Achha. So now here, as we perhaps know that the various hash functions. So there are various type of ways in which we can perform hashing. Okay. So one is modulo division, which we have used over here, modulo division. The second method is the folding method, and third method is the mid square method. So modulo division method we have already used here. The example that I said that used the concept of modulo division. Next, another method is there that is called folding. So folding generates a hash table of this format, and third method that is there, that is called the mid square method, right? So mid square method I have not shown due to the paucity of time. So basically what we can do is that we can compare the performance of these hash functions. We can compare the performance of these hash functions, right, using a set of parameters. Okay, so three methods: modulo division, folding, mid square. So what are the parameters? One is hash table size. We find out that in context of hash table size, mid square is very poor performance, is showing a very poor performance, isn't it? Its size is very high. Similarly, number of large item sets generated, there also mid square is very poor. But whenever we think of the concept of cycles, we have investigated and we found out that in case of cycles, mid square method does not contain any cycles. Number of association rules is more or less similar. Tuples required for storing the concept maps, that is also similar. Okay. So implementation in mobile learning environment. So we had implemented this, as I said, using an Android emulator. But prior to that, what we have done is that we have developed an architecture. So before developing the architecture, we had taken the concept map. Actually comes from the theory of meaningful learning. So I am not very much an expert in terms of education, but whatever I had learned when I created this, when I developed this paper. So basically concept maps comes from the concept of meaningful learning. So meaningful learning consists of three components. What are the three components? One is lesson organization, another is presentation of learning task or material, another is strengthening cognitive knowledge, cognitive organization. So corresponding to these three elements, we have developed three modules in the architecture. What are the three modules? One is concept map generator module, second is the learning module, and third one is the evaluation module. So these three modules we had developed. So these are the three modules that we have. We had used a Oracle database. There is a knowledge base which is used. The inference engine works on this knowledge base. Okay, and here in one of the databases there is the study materials, question bank, test results, student general data, and obviously students reading behavior. That means which portions he likes to read a lot, those things. So we had called this as IDRLS, Intelligent Diagnostic and Remedial Learning System. At the interface of this there are two devices. It can be a personal computer or it can be a mobile. It can be anything. So over here there are three modules. What are the three modules? The first module works on the TIRT and ASST. What is AST? The original data from where we had started our study. That is called the ASST. That is the answer sheet summary table. So the second module, it stores the study materials corresponding to each concept. And the third module is the main thing. It will conduct the test and it will store the marks. So for that, conducting test. So since our aim was to conduct the test in an automated fashion, so the question bank was necessary over there. So this is basically the functional components. Okay, right? So concept map generator module, learning object construction module, evaluation module, and the test results. In between there is the learning module. Okay, so to understand how this worked, we had taken a course on Introduction to Java Programming. So this Introduction to Java Programming concept course had 12 concepts. Okay, and corresponding to each of these concepts there were 10 test items and there were 8 students. So we had written a C program on the data that was generated, and this was basically the output of the C program. So this was the concept map that was created based upon what we have learned. So this was the concept map that was created over there. This was the concept map. You see there are 12 concepts, the relationship between the concepts, and after that we had removed the cycles. After removing the cycles, this is what we had obtained. So basically, to understand how the entire thing, we had created a flow diagram. So what is this flow diagram? So initially the students are learning the subject in a traditional manner. So after learning in a traditional manner, the students are appearing in a pre-test. We are calling it pre-test because before the remedial learning, the test in which the student is appearing, it is called the pre-test. So constructing the learning sequence using concept map on the basis of pre-test results. Pre-test results means the ones that I have shown. Based upon that we had constructed the concept map. Based upon that we had constructed IDRLS, that is the architecture. Now students appear in a test in one of the concepts. So if a student appears in a test in one of the concepts, there are two things that can happen. So either the student will pass the test or he will fail in the test. So if the student passes the test, he is going to learn the next concept. But if the student fails in the test, he has to learn the concept once more. So this entire thing we had implemented in an Android emulator. Actually our target was to implement this and show in a mobile actually, but we could not get the time. So over here, that corresponding to the learner system corresponding to the learning sequence generated, so we had shown this. Okay, over here what happens, a student had given the exam, so this was the feedback that has been received. You have learned the document poorly means the certain concept, right? So what you have to do, you have to go back to this, you have to go back to the previous concept. So basically C6 is arrays. That means a student has given an exam on arrays and he has failed poorly, so he has been asked to revise the concept of loops. Once he revises the concept of loops, he gives the exams corresponding to the loop and he comes back to the concept of arrays again. So obviously any study these days is incomplete without any statistical results. So the learning experience that was there, so the learning experience we had implemented corresponding to the IDRLS, we had implemented using multiple regression. So in multiple regression what we had done, so we had divided the entire learning process into 3 steps. What are the 3 steps? First is students are given to learn the subject in a traditional manner. That means in a general method the student learn the subject, right? So that we had called as trad learn, the traditional learning. Next, the students appear in a pre-test leading to IDRLS development. So that is called IDRLS construct. And finally, they appear in the test concept wise and identifying remedial concept, that is called relearn. So based upon the data that has been done, that has been derived, so a regression equation was developed. So it was called test results is equal to this so much. So you will find out if you check this part 0.019 into trad learn. What does it mean? That means the test results is dependent, is directly proportional to traditional learning, but here the sign is negative. So what does the sign negative mean? So this means to say that IDRLS construct is inversely proportional to test results. Here also it is negative, means remedial learning again is inversely proportional. Okay, so this was the summarized results along with the regression coefficient, the standard errors. Okay, and these are the results that I have said. In the first case it is directly proportional, in the second and third case it is inversely proportional. So the present study that we have, we had compared with the work that are there, that has been constructed by several gentlemen, especially from Taiwan. Actually in this field, when I worked upon this field, I found that most of the people that are there, so researchers, they are basically from Taiwan actually. So we had done our study based on the results that were given by these researchers. These papers all are highly cited papers and all of them are there in the Web of Science. In fact, this paper that I am discussing, this is also published in Web of Science actually. Okay. Achha. So over here, so the results that are there, so results are very much proportional to the studies that has been done by these researchers, right? So inferences is that we have a reduced size of 2 item sets, best results are obtained from modular division, and we are saying that the learning is automated in nature. Okay, is automated in nature as concepts maps generated immediately on inputting TIRT and ASSCT, and finally concept map generated is independent of data mining algorithm. Okay, that means over here we had used an algorithm called the a priori algorithm, very famous algorithm. So this a priori algorithm has been written by 2 gentlemen perhaps around 1990s. Their name is Srikant and Agarwal. So they are in USA based scientists. So in my view, I have seen a lot of papers in computer science. So this paper is cited by at least 50,000 researchers. Okay, number of citations is close to 50,000, and in my view, in my limited knowledge that I have of the subject of computer science, probably this is the highest cited paper in computer science, probably. Achha. So next we had a concept, this was totally our concept, our own idea actually, called weighted concept map. What is this weighted concept map? So weighted concept map means to say that corresponding to each of the concepts that are there, we are assigning certain weights. So it can happen that all the concepts may not have the same weight. Some concepts may have a higher amount of weight, some may have lower amount of weight, and so on. Okay, so over here we had given certain weights to the concept, and then of course we had used statistical methods to indicate the effectiveness of weighted concept map over the traditional concept map. So this is what we are saying. So this is a typical concept map with correlations. So this is the concept map that we originally had. So we are starting from C1, then C2. From that we have C3, C4, which can be, these 2 paths can be done simultaneously, and so on. So the proposed requirements is that we are giving weights to each of the concepts. Okay, and obviously the sum total of weights that are there, the sum total of the weights are equal to 1. Whatever is the sum total of the weights, the sum total of the weights will be equal to 1. So for the learning path C1, C2, C3, C6, we are calling C1 as the root concept and C6 as the final concept. We had taken a concept called degree of learning. Degree of learning means what happens when we go from root concept to the final concept. There can be several paths. Okay, so which path we choose, that will be given by degree of learning. So whichever path will have a higher degree of learning, we are going to choose that path. For example, we have taken 2 paths, 2 degree of learning we had found out. One is D61 we have called, another is D62. So if D61 is greater than D62, what does it mean? So it means that D61 has a higher degree of learning and we should adopt D61. Okay, right? So we can generalize this concept. If there are k learning paths, right, corresponding to the k learning paths, we have to compute the degree of learning for each learning path and check which one is the best. So this is again, I won't bother with this computation. So we have taken the implementation and assessment. Okay, so we have done this to a group of physics course of force and motion being taught to a student of class 8. Okay, from that we had taken some data, and based upon that we have computed the learning path. So this was the corresponding concepts we have done, and this was the learning path that we had. So again, we had repeated the concept for introduction to a course on algebra for a student of class 6. Based upon that, we had given some weights, and we had again constructed the remedial learning path. Right? So what is the process that we follow? Now our target, there are two methods in front of us. One is the concept map, another is the weighted concept map. Right? So our aim will be to compare concept map with the weighted concept map and which one is better. So over here, students of a class study the course in a conventional manner, and then a pre-test is conducted on these students. Okay, so those who fail in the pre-test, they are divided into 3 groups. So what are the 3 groups? So one is in traditional method, second learns using concept maps, and third with weighted concept map. And of course we compare their results with something called a t-test, and these are the results, right? So these results clearly show that weighted concept map offers a better result. Okay, now if I want to compare between concept map and weighted concept map, so what is the difference basically in terms of approach? So all concepts have equal weight in concept map, and in weighted concept map different concepts have different weights. Degree of confidence in a concept map is not there over there, right? Here we are using the computing the degree of learning. The nature of the learning over here is based upon the own certain concept and the previous concept. All right. And what is the difference here? Here the focus is on the remedial learning part, and use means used when the number of concepts and association rules are low, and over here when it is high. So inferences is that concept map identifies only the concepts that need additional learning, but the weighted concept map that we had, so the weighted concept map identifies the entire learning path, and we have applied the results to a set of middle school student, and as per our study, I am repeating the word, as per our study, the results of weighted concept map are better than the concept map. So these are the references, all the references that I have taken from, they are from the Web of Science. Okay, right, highly cited papers, all these papers are highly cited, at least 300 to 350 citations, all these papers I have taken. Okay, right, so which contains these concepts. Okay, so I think that is the end of what I had to say. If we can, if there are some questions.
Thank you, sir, for your enriching your talk. Now we will open the audience for your questions, clarifications. Yes, ma'am.
Sir, I have a question that when we are considering the weighted concept maps, then why we are taking the weightage so that their summation is always equals to 1? That is, it is always necessary to take the weights like summation always will be equals to 1.
Yes, actually we have to have a certain control. Actually, let us say there are various concepts map we want to consider. Okay, so in some case if we take the scale as 1, in some case if we take the scale of 2, 3, whatever, so the comparative study between them will be difficult. So that is why we have kept it to 1. Okay, as a benchmark actually.
Maybe 1
Yes, yes. It may be, you can keep it, think like this. 100% you can think like this. Then you can think that some concept has 15%, some 20, some 30, some 40, in that way, so that the sum total comes to 100 in that way. A certain benchmark actually to understand.
Okay, Mike there.
Hello sir, very nice presentation I would say. One question, not question, that I think it is quite relatable to I say a rash model, item response theory.
Yes, yes, yes.
Very much relatable.
Yes, yes.
And where I studied the rash model and I used it in my studies also. Sir, you when you took the weighted concept maps, no? Here you take the weight of the concepts, not the questions.
Yes, yes, yes.
You have considered the questions with equal weightage, na? Same.
That I have considered same, yes. But actually,
in rash model, they actually it is kind of psychometry part. So in they use the for different weightage for different questions.
Yes, yes. I think that side can also be investigated upon. Actually, this is what we had thought. There is nothing.
No, I just want to say the explanation. Thank you. No problem.
Actually, see, item response. Kindly sit down. Item response theory is something. See, whenever we started the study, so we had started from the angle of computer science, but after going in a little bit, we found that we needed to know about education, which in our case was almost like null set actually. Okay, so we had learnt a little bit. I had taken up this David Ansubel's model, which was called the theory of meaningful learning, and that item response theory which you are telling. So that is some papers I have referred over there. They have used that also. Okay, and second thing is the weighted concept map. This is what we have thought. There is nothing as standard as weighted reference, but when we send this paper, it has got a good feedback also. So we can, yes, about the questions as you were saying, we can definitely think of that in our subsequent work.
Any other questions we have? Anybody? So do we wait for Tina?
Let us give a round of applause to Dr. Anil Acharya. He is very, very passionate about this subject. Maybe it's our PhD thesis becomes our baby, our first baby. Non-biological baby, and I think he's so passionate about it. And when we were discussing about the possible chapter, he said, "No, I have already decided a topic." So we let him to have it, and you would have realized it from his presentation how passionate he is. So thank you so much, sir, for sharing your baby, your intellectual baby with us, for nurturing and enriching us. Thank you so much,
Thank
sir.
you, Father. I think one thing that is probably created a little bit of problem is that there are a little bit too much of maths. I think that probably created a little bit of a problem, perhaps. Could have actually, but then I had tried to make it as simple as possible. Okay.
We will then now conclude this session. Any other queries? We will take a break now of about half an hour and come back at around 3:45 for our valedictory session and giving away of the certificates. Okay, so we have tea waiting outside, so you can please have an
I know you don't need, but we need it.
we have our certificates coming, so you have to wait.
To be honest, the certificate has gone to St. Xavier.
For father's signature.
For his signature. It will take little time, so we are buying little time. You don't need, you would prefer to have it one go.
Actually, father himself wanted to sign each certificate, so we made it a point to send it to him. So it is just coming from St. Xavier's and we are just buying some time for it.
As soon as we won't be waiting for it to come. We will start by the time we start After receiving the certificate, the doors will be open for you to go home.
We will have a,
Hot cup of coffee waiting for you there.
yeah, we also have plans to take a group photo at the end. So please don't leave without taking the group photo, even if you have received the certificates.
Okay. Since you are not very keen on going, let me give you a little small homework. The homework is a short feedback. Again, you see the QR code. Please just click on the QR code. There is it will take 2 minutes for you to fill in the query, the Google form. It has got just you need to click. Then you type a few words. That's all. Very brief feedback. Now you can, after clicking it, you can move out and you can just fill it in and see. Yeah. So once you click it, you can go out and you can finish it outside. There is also, in case if you need, we have also short URL. Hey, can you? Shavai Pachiki. We can also give you URL. Huh? Type करते हो अभी. सवार भी इटा family ना होते पारे. Hey. সুচরিতা স্যার কি হয়ে গেছে
Is it working? Working, no?
এটা তো এখানে আর লাগবে না এই মাইকটা অফ করতে হবে
এটা মাইকটা অফ করে দাও তো